Hello everyone, welcome to video number 10 of AP Computer Science A. In this video, you will learn about Boolean Algebra and prepare for the multiple choice question portion of the AP exam. So Boolean Algebra allows us to simplify Boolean expressions. So Booleans are represented by variables, and if it's true, then the value of the variable is 1. If it's false, then the value of the variable is 0. So here are and or operators. So A and B is the same as A times B. A or B is A plus B. And the normal rules of arithmetic apply here. The only difference is 1 plus 1 is equal to 1 in Boolean algebra. And here's the not operator. So you denote it by overlining the variable. So not 0 is equal to 1 and not 1 is equal to 0. So here are some general rules, and don't try to just remember them all. Try to remember instead why they are true. That will make it a lot easier to remember. So first we have A times A equals A. That's because 0 times 0 is 0 and 1 times 1 is 1. All right, and a similar logic applies to give A plus A is equal to A. And then you can use the distributive property in Boolean algebra just like you can in regular algebra. A plus not A is equal to 1. That's because one of these has to be 0 and one of these has to be 1. 0 plus 1 is 1. And the similar logic gives you that A times not A is 0. And then A plus 0 is A plus 1 is 1. And then not A is equal to A. So two nots cancel each other out. And this last one is a little more complicated to prove. So try to remember it if possible, but if you can't remember it, that's fine. You likely won't have to use it. And now here's De Morgan's law. So De Morgan's law is very helpful in helping us simplify. So it tells us that not A or B is the same as not A and not B. Not A and B is the same as not A or not B. All right, so now try to simplify these two by yourself. So if you need more time, pause the video here. The solutions will come in 3, 2, 1. All right, so for number 1, so we first distribute it to get AA plus AB, and then remember that A times A is the same as A. All right, and then now we can factor it again. So we have A times 1 plus B, and remember that 1 plus anything is just 1. So overall, this is equal to A. And now for number 2, we use De Morgan's law. So this becomes not A times not B. And remember that two knots cancel each other out. So we're left with not A times B. And now we are done. Before we get into the MCQ practice, first you should know about some information about the MCQ section on the AP exam. So you have 90 minutes to solve 40 questions, which is an average of 2 minutes and 15 seconds per question. When you're doing this practice, which is 10 questions long, I would suggest putting on a stopwatch to keep track of how much time you take on the practice, just so you have an idea. Don't set a time limit because since this is likely your first time doing MCQ practice, you can expect it to take longer, and that's totally fine. If you're going to continue doing more MCQ practices in the future, then you can start setting time limits. If there's a question on the practice that you don't know, just skip over it. The hardest question on the practice is number 7, and I expect a lot of you to skip over it. So now onto the types of questions. So there's determining the result of executing a code segment. This is the most common type. And then there's also completing a section of code, finding and fixing bugs, and determining which pieces of code properly perform a given task. So now you may start the practice. In the description, there's a link to a Google Slides presentation of the MCQ practice. So pause the video here, click on it. The solutions will start coming in 3, 2, 1. Problem number 1 So we have this method and we need to determine what it prints out. So we have two parameters that are both strings, and then we have string str1 equals word1.substring 02. Remember that the 0 is inclusive and the 2 is exclusive. So str1 is basically the first two characters of word 1. str2 is word2.substring word2.length minus 1. So this is the index of the last character of word 2. So going from this index to the end of word 2 is basically just the last character of word 2. So therefore str2 is the last character of word 2. And then we have string result equals str2 plus str1, and then print out result dot index of str2. And notice that str2 is always at the front of result because result is str2 plus str1. Therefore the answer is A. 0 is always printed because str2 is always at the very front of result. Problem number 2, which of the following statements assigns a random integer between 25 and 60 inclusive to Rn? If you remember in video number 10 of Java Fundamentals, you learned about the math.random method. That returns a random number from 0 to 1, including possibly 0, but not including 1. So if you do math.random times n, and then cast it down into an int, that will return a value from 0 to n minus 1. So if you do math.random times 36, which is 60 minus 25 plus 1, that will return a value from 0 to 35. And then if you add 25 to it, then the bounds will change to 25 to 60. So therefore the answer is D. Problem number 3. So you have to use Boolean algebra in this problem. So this Boolean expression turns into A times the quantity not A plus B. And then you use De Morgan's law. So this turns into A times not B. Remember that A times not A is always 0. So therefore the answer is 0. And 0 is false. So therefore the answer is B. The value is always false. Problem number 4. So what is printed when this code segment is executed? Alright, so let's just walk through this code step by step. So first we start with value is 48, and then div is 6. Alright, and then we have while. So while val is even and div is greater than 0, if val divided by div yields a remainder of 0, so if they're divisible, then you print out val and then the space, and then after that you do val divided by 2 and div minus minus. Alright, so the first time you run this while loop, you see that 48 is divisible by 6, so therefore you print out 48. And then now changing val and div, so val changes to 24 and div changes to 5. And this while loop is still true. Val is still even and div is still greater than 0. Alright, but this time this if statement is not true because 24 is not divisible by 5. Alright, so we don't print anything out, and then we edit val and div. Alright, so now this while loop is still true, and then 12 is divisible by 4, so we print out 12. Alright, and then val then changes to 6 and div changes to 3. 6 is divisible by 3, so then we print out 6. And now val changes to 3, div changes to 2. And val is no longer even, so therefore the while loop stops after that. So the output is A, 48, 12, 6. Problem number 5, we have an integer array nums which has been declared and initialized with one or more integer values, and we want a code segment that will change every element in nums to its square. So which of these pieces of code does that properly? So with code number 1, we have an integer k equals 0, while k is less than nums.length. So nums k equals nums k times nums k. That does edit it correctly. However, the problem with this piece of code is that k always stays at 0. It never increases. So therefore, this while loop will just run forever, and only the first element in the array is changed. So therefore, 1 doesn't work. 2, we go from k equals 0 to k is less than nums.length. So this goes through every element of nums, and it changes each element to its square. So 2 works properly. And then 3, we're using a for each loop. Remember that for each loops can only be used to access an array and not edit it. So therefore 3 doesn't work. So the answer is A, 2 only. Number 6, we have this code segment. What are the contents of numbers after the code segment has been executed? All right, so let's run through it step by step. So first, we add 1. All right, and then we add 2. And then, so we add at index 0, 3. So index 0 is right here. And then we set the element at index 2 to 4. So this becomes 4. And then we add 5. And then we remove the element at index 1. All right, so we're left with this, which is answer choice D. Problem number 7. So this one's the most difficult one. So let's run through this code. So let's use this array right over here, or sorry, array list. So we want to remove all of the even elements, which is 6 and 2 in this list. So let's run through this code step by step to see what's wrong. So we start with I equals 0. So that's this 5 right over here. So if the element is even, then remove it. And then after we run this for loop once, we have to increase I by 1. All right, so running it on 5, we see 5's not even, so we don't remove it. And then I becomes 1, so that corresponds to this 6 right over here. And 6 is even, so therefore we remove it. So the list becomes this right over here, and we increment I by 1. So now it's 2, which is this 7 right here. And notice how we skipped over this 2 right over here, because the indexes of all subsequent elements change by 1 when a list element is removed. So therefore, the answer to this question is E. The code segment skips some elements of my list because the indexes of all subsequent elements change by 1 when a list element is removed. So if you have 2 consecutive even elements, then it wouldn't remove the second one. And the way to fix this code would be, after saying mylist.remove I inside of this if statement, you also add a I minus minus line, and that will make the code run as intended. Question number 8. So we have this code segment. So for int, we have 2 for loops. All right, so let's run through this code and see what it does. So we start with row equals 0, and then we go all the way to points.length. So we just start with 0, and then 1, and then 2, and then 3. All right, and then for int column is equals 0.0.length minus 1. So that's just the length of a column. So that's just the length of a row in the array, sorry. And column is greater than or equal to row, column minus minus. All right, so first we start with row equals 0. So, and then column starts at this element right over here and goes down. All right, so we print out 15, 14, 13, 12, and 11. And then after that, we indent, and then row becomes 1. So then column starts here. So we print out 25, 24, 23, 22. All right, so remember that row is 1. So right now, column is also 1. And then after that, column goes down to 0. And 0 is not greater than or equal to 1. So we stop after printing out the 22. And then we indent, and then row becomes 2. So we print out 35, 34, and 33, and then stop. And then we print out 45 and 44. So therefore, the answer to this question is D. Problem number 9. So consider the following code segment and what is the value of sum as a result of executing the code segment. So we have a for each loop that goes through every column of this array. So we first have this column, and then this column, and then this column. And then for int y equals 0, y is less than x dot length minus 1. All right, so remember that if we want it to go through every element in the current row, we need to make it say y is less than x dot length, or y is less than or equal to x dot length minus 1. If you do y is less than x dot length minus 1, that will skip the last element in the row. So therefore, we add these 9 elements right over here. If you add these 9 elements right over here, you're going to get 54. So the answer is B. Question number 10. So we have the following class definitions, and then the following code segment appears in a class other than thing 1 or thing 2. So because of polymorphism, this object is a thing 2 object when it's running. So t.calculate 2. So that runs this method right over here. So first we increase n by 2. So n becomes 4. And then super.calc 4. So we come here. So we first multiply n by 3. So therefore it becomes 12 for this method right over here. All right, and then we print out 12. And then now we can go back to this line of code. And remember that multiplying n by 3 only applies to this method. It doesn't apply to this method. So therefore, n is still 4 in this method, so we print out 4. So we printed out 12 and then 4. So therefore, the answer is D. And here is the answer key if you want. And now we are finished with this video. So I hope this was super helpful and fun. In video number 11, which is the last video of the entire series, you will get practice with the second part of the AP exam, the FRQ. So thanks for watching, and I'll see you there.